Hi and welcome back. Well, today I'm going to take care of the interpolator oscillator, and this is one of the models that has less components on it, and the purpose of this oscillator is to tune the oscillator itself in order to have a reading here in the scale, including the scale that should appear here in this window. And with that, we'll give to the operator the possibility to understand with the calculation to the frequency that is tuned on the instrument. Well, it's quite complicated the way it's not a direct frequency reading on this instrument. And I will explain more in depth later on when the instrument will be complete and able to run, hopefully. So, at this point, I will go ahead with cleaning. I have already removed the top cover. We have already seen the inside, but I want to see here. I have already removed the screws, and I want to see how it is down below here. Well, it's not too bad actually. Not too bad. That seems there are a bit of oxidation signs over there as well. But all in all, it's not too bad. We don't know about the state of those capacitors, but we have in total 4 what I believe to be paper and wax capacitor, 4 of that, plus this one, which I believe is an electrolytic, non-polarized electrolytic. Let's give a look to the schematic. C47, and yes, C47 indeed is on the 250 volt line, so I suppose to be a non-polarized electrolytic one, or we will see. By the way, this is the schematic. As we can see here, we have the oscillator, and this is the variable capacitor that is moved by this knob here. And clearly here is driving the vertical deflection of the scope that we have seen in a previous video. So when this frequency match or is a multiplier of the frequency, the incoming frequency, and no incoming frequency, we should have a pattern in the scope that let us understand that we are on the measure. Well, I think that we can test this standalone like that, since it's simply an oscillator. So we should be able to see a frequency here, and I will check in the manual which kind of frequency should provide. So let's go ahead with the cleaning. I will test the tube, and I will see the result, and then we will test with power supply. Well, unfortunately, the inner scale it's touching the outer scale, so I'm going to remove it and see if I can fix the problem. And this is the scale with the knob removed, and as we can see, we have a lot of dusty, and this is the main reason why it's not turning free, I believe. So I will clean off camera and see the final result. Well, I ended up with the removal of the wall scale, the dials, and indeed there is a lot of dusty down there, sort of sand that make it very scratchy, and you can feel by rotating that something it's preventing a smooth rotation. So let's clean it up and see the result. Okay, the handle now does rotate very free, and the dial here now is visible. So we can proceed with tube test and unit power on. So let's see if we can have some success here. All right, I have covered the unit just for safety. So I already have raised it up slowly with variac, and yeah, I let it run at lower voltage for a while. So we should be able now to go directly to full power, and indeed is that the case. So I will move the camera in front of the oscilloscope. Okay, we are rising up voltages, and indeed we have signal. Now this oscillator is meant to work from 15 to 20 kilocycle, and very precise, again an order of 0.0014 or 15%. And this is a variable oscillator, so moving the handle, the knob, as you can see, it's changing the frequency. Now what I want to check is if when I am at 20 kilocycle, if the scale is matching the numbers. So, well, that would be really incredible, but I don't believe that we will have such precision right now. Yeah, let's call it yeah, increase a bit more. It seems that we are not able to reach 20. Okay, we have a capacitor here. I moved the camera down so you can see what I'm doing. Here we have this is a variable capacitor, and by adjusting this I can adjust the oscillator frequency. Now I've seen that when this is at 0, I should have an even frequency, but I'm having just no sense numbers. So I think I will try to perform the alignment and see if I can reach some more intelligible numbers. Well, while I was trying to adjust the oscillator, I found that this capacitor were completely leaky and was transferring 180 volts to my frequency counter, and likely I didn't fry it since it's in AC mode. Moreover, this oscillator can't be really adjusted so much. It seems that we only have this capacitor here and this in front, but we have a sealed, let's say, choke. It's not a choke. A sealed coil that include also additional components. As we can see in the dashed area, we have 2 coils and some capacitors and a resistor. The problem that I'm finding is that it doesn't track as it should on the scale. So the first frequencies, it's increasing more than 100, and then at the end it barely reached the end point. So the tracking is completely unusable, I would say. So, and indeed this scale should give us the indication of the beating of the incoming frequency, so must be really precise. So I wonder if we have some, hopefully it's just a matter of component here, because if we have a problem in the sealed coil, yeah, we are done. Well, I think I found why it's a nonsense, the dial here relevant to the indication of the frequency counter. This calibration book, actually, it's a specific book for this oscillator. And indeed, I have made some tests. I'm now at what here it should be read as 214.5, and 214.5, if I go to the right page, I'm losing here, should be 7.84. Now I think this will beat with 10 kilohertz. I'm at 1784. So if I subtract 10 kilohertz, I have the right frequency. So if I go to 23, let's see, 23 should be 785. Look at that, 785. So I think that this is the purpose of the calibration book, is to translate the reading on the dial to the specific frequency. So if I go, let's say, on 250, let's see if I can find the page. Sorry for the movement and the weight, but I'm just discovering with you. 0.3, which is like that. So let's see if we track 8.37. It's almost there, 38. So I think we can consider this. We can assume that it's working as it should. So yeah, I just understand in this moment that the purpose of this calibration book, and it is specific on serial number 499. Let me grab the front panel. Well, unfortunately, this is serial number 947. So it's not the proper calibration book, but seems to be not so far away. So I think it's usable. Well, clearly I can consider it working, so I will put aside and go to the next one. This is the next module that I will take care in the next video. This is the proxy oscillator and multiplier. There is a bunch of work to do here. So I hope you have enjoyed the series so far, and see you soon.